Hi, this is an overview of the Vieta Space Math Editor and the browser add-on. To show you the basic features, I'm going to walk through solving this calculus problem. It's a double integral between two curves. Since I already wrote the problem in Overleaf, I have the LaTeX for it right here. I'll just copy that and paste it directly into the Vieta Space Editor. First, I want to express this double integral in terms of dx and dy instead of dA. I'll select the double integral symbol by holding down Shift and then the left arrow key. This brings me to one of the most central features, which is the Smart menu, which you open by pressing Tab. It shows me variations of the symbol I've selected. I'll just replace the double integral with a standard single integral sign. I need two of them for a dx dy integral. And since I just inserted the integral, it's in my recent symbols, so I can just click it again. But to show the search, I'll type int instead, and you can see it shows up right here. All right, let's add our bounds, starting with dy. The lower bound is y equals x to the power of 2. Now, as I type this, you can see the text in the script is getting quite small and hard to read. To fix this, I'll enable the auto zoom feature. You can toggle this from the menu or by pressing Ctrl-Shift-Z. With auto zoom on, I can move the text caret into any container like a subscript, and the editor automatically resizes the view. This normalizes the font size, which would normally be smaller, to match the main editor's font size, making it much easier to read and edit. To create a subscript, I just press the underscore key, and for a superscript, I just use the caret key. You'll notice a small space before the dy. This came from the original LaTeX that I pasted in, and it appears here as a spacing kernel object. I can fine-tune its width in the toolbar, or I can simply press the spacebar to increase or backspace to decrease it in small increments. This completes our inner integral. Now, I need to wrap this entire expression in parentheses for the outer integral. So I'll select everything and just type and press the opening parenthesis key. The editor automatically wraps the selection and adds the closing parenthesis. But now the parentheses look too small for the tall expression inside. In LaTeX, you'd solve this with a left-right command. Here we call it a delimited group. With the group selected, I'll press Tab for the Smart menu. The first suggestion is autoscale delimiters, which appears because my selection contains delimiters. When I apply it, the editor makes all the delimiters in the selection autoscale, including the ones inside my expression. I don't actually want that, so I'll simply select the inner parentheses and from the toolbar set their size back to small. Now I'll add the bounds for the outer integral. This editor is a dedicated tool for writing individual math expressions, not a full note-taking app for solving long, multi-step problems. While it works for simple derivations, its main purpose is for single-line equations. For a workflow like this, you'd ideally use it with a dedicated note-taking app. There are quite a few that render LaTeX, like Notion and Obsidian. I typically use Notion, so I'll be pasting my steps there. I can press the copy button to copy the LaTeX for the whole equation, or just select a part of it and press Ctrl-C. Then I can go over to Notion and paste it in. All right, let's move to the next step. I'll create a new equation. I want to start by copying the integral from the previous step. I can use the sidebar to navigate, or I can simply use the page up and page down keys. I'll press page down to go back to the previous equation, select the inner integral, and copy it. Then I'll press page up to return to my new equation and paste it in. While we're here, a quick note on the sidebar. You don't have to be signed in to use this editor. You can go to the site and start typing immediately. Your work will be saved locally in the browser as local equations. If you do sign in, your equations are saved as synced equations, which give you access to them from any device, along with a full version history, allowing you to restore or fork any previous version of your work. Okay, back to the original problem. Let's maybe start with the inner integral, but as an indefinite integral first. So we'll find the family of antiderivatives. We will treat x as a constant and integrate with respect to y. This gives us this intermediary expression. I will write x times y plus, I'll type y to the power of 2, and then select it and just press the / key. I'll just add the 2 in the denominator, and finally the constant of integration. Now I'll copy the original inner integral, create a new equation, and we'll solve the definite version. To solve the definite integral, we will need to evaluate the antiderivative at the bounds. Now let's imagine two scenarios. Either the step is simple and repetitive, and we just want to get to the next part, or it's very complicated and we want some help. This brings us to another major benefit of this digital workflow, which is interacting with AI tools. This editor makes it much easier. I'll just copy the expression, go to ChatGPT, and paste it in with a prompt like, please evaluate this. Then I'll go back to the editor, press page down to our previous step, and copy the antiderivative we just found, and paste it into ChatGPT as well, adding something like, and here is the antiderivative if it helps. All right, ChatGPT has given us the solution. This is a perfect time to show you the Vieta Space browser add-on, which works on Chrome and Firefox. Its goal is to let you copy rendered math from any website. Normally, if you try to select and copy this rendered math and you paste it somewhere, like in this chatbot's input field, you get a mess of broken text. But with this add-on installed, I can just click on any rendered equation and it's now copied to my clipboard. I can paste this into the chatbot as well if I have any follow-up questions about this particular expression. But for our purposes, I'll just go to the response from the chatbot and I'm going to copy the second to last step. I'll go back to the editor and paste it in. And because the original LaTeX used a left-right group, the editor pastes it as a delimiter group. Let me fully simplify this expression. So I want to dissolve this group, and I can dissolve it by pressing the dissolve button in the toolbar, or I can just manually delete all of the delimiters. And as you can see, once the last delimiter is gone, the group collapses. Now, I want to show a few more features that didn't come up while solving this problem. Let's go back to our first equation. To add plain text inside the math environment, I'll press Tab and search for text. This inserts a text block. I'll type where and another text block that says and. Inside these text blocks, you have full styling control from the toolbar, so you can easily add bold, italics, or other formatting. As a final example, I'll create a 2D rotation matrix. I'll start by typing R for the matrix name. By default, letters are italicized as variables, so I'll select it and use the symbols toolbar to change it to bold upright. For the angle, I'll open the Smart menu. If I don't remember the name of the symbol I'm looking for, I can just type a keyword like angle, and it gives me all the related symbols. So I'll just choose theta. To create the matrix itself, I'll press tab and just type 2x2. The menu gives me options for a plain array or arrays with delimiters. I'll choose one with brackets. This creates a 2 times 2 matrix already wrapped in a delimited group. It also adds a small amount of negative spacing, which you can see in the annotation line below. And I can adjust this negative spacing manually from the spacing toolbar. I'll start filling in the elements. Notice that when I type COS, it autocompletes to the correct cosine operator function. Now that I'm inside an array, the context-sensitive array toolbar appears. From here, I can add or delete rows and columns, change column alignment, and more. You can also do this with the Smart menu. If I'm in a cell, I can press Tab and move right or move up. What if I wanted to change this to a 3D rotation matrix, say around the x-axis? First, I'll add an x subscript to the R. Then I'll go into the matrix, open the Smart menu, and type add row above, and then add column left. Now I have a 3 times 3 matrix, and I can fill in the remaining values. These are the majority of the core features. You can find a complete list of all the shortcuts in the Settings menu, or check the full features documentation on the documentation website. I hope you found this guide useful, and thanks for watching.